When I first began transforming my reef tank, I wasn't trying to make it beautiful. I was trying to make it alive. A few years ago, I watched my reef community unravel. It was a slow collapse, ending in a massive nitrate spike that hit over 200 parts per million and wiped out almost everything. The fish that once thrived began to fade. My clownfish pair eventually died. My Scopus tang eventually passed away. My engineering gobies also departed my fish tank. They were lost. It wasn't aggression or bad luck. It was a habitat problem that was in my system. I had built a reef tank for looks, but it wasn't built for life. That realization changed everything. I focused on getting the water chemistry right, not just the decorations. I stabilized the nitrates, and the system was finally healed. In the fall of 2024, I added a school of 9 green chromis, ready to see life return. But the losses continued. Their numbers kept thinning. 9 became 7, then 5, then 3. It wasn't the water quality anymore. I began to give it some deep thought. I realized I had only fixed half of the problem. I had fixed the chemistry, but I did not fix the habitat. The fish had nowhere to feel safe, no structure to form their social groups, with no place to truly belong. So, with those last 3 chromis as my motivation, I took the existing rockwork, broke them into smaller, more natural pieces, and built what I call a branching forest design, or a habitat negative space aquascape. The advantage? It had open swimming lanes between the coral structures, just like the wild coral thickets found in the Solomon Islands. The behavior of those remaining 3 chromis changed almost instantly. Some might have said it was overnight, but for what I saw, it was instant. The aggression stopped. They began schooling tightly, darting through open water and finding safety in the structures. I realized they were finally home. That single design change became the foundation for what I now call the Resilient Reef Biotope. This isn't the story of a tank. It's the story of a living experiment. One that asks whether a glass or acrylic box can replicate the inner workings of one of the most complex ecosystems on Earth. The key was understanding what went wrong, not once, but twice. First with chemistry, and then with ecology. The system didn't just fail because of bad water quality. The chromis were failing because I had given them no place to belong. I didn't give them a place to call home. So I started from scratch with their behavior in mind. I designed it for those 3 survivors and for the fish I hope to one day host. Wide corridors, coral thickets, and open water zones where schooling fish could form their social hierarchies and rest at night without being picked off by the bullies. I stopped seeing teeny creatures as pests and started seeing them as what they really are: the maintenance crew of a functioning reef. You see, in nature, it's not just the corals that keep the lagoon alive. Oh no. It's the hidden world beneath them, the animals that eat waste, the janitors, the garbage collectors, the creatures that filter water, the invisible workers that recycle every scrap of life back into the system. In my biotope, all those roles were represented. The hermit crabs and conchs keep the sandbed alive, constantly turning it over and breaking down debris like detritus. The sponges and colonial tunicates filter water like natural machines or filtration systems, pulling particles from every gallon that passes through them. And the two tiger pistol shrimps work together around the clock, just like shrimp do in the lagoons of the Solomon Islands. They're constantly digging, aerating the sand, feeding the microscopic communities that fuel the coral's world. This, what you see, isn't decoration. It's ecological design, guided by the same natural principles that govern a living lagoon. In the early years, chemistry was my downfall. My nitrates hit over 200 parts per million, and the phosphates, they climbed over 4 parts per million. What I basically created was a chemical graveyard. Now today, that balance has been restored, not only through dosing and using special equipment, but also through biological harmony. My tank now runs at good balanced nutrient levels. Nitrates between 5 and 10, phosphates around 0.1 to 0.8. That's the same natural balance that fuels coral growth and mangrove health in a mangrove lagoon. And that's the ecosystem that I'm trying to replicate. Every leaf, every mangrove root, every microscopic colony contributes to that chemistry. The system breathes, literally. As oxygen rises during the day and carbon dioxide at night, to dissolve oxygen levels, I maintain simply support what the ecosystem already does naturally. Recycling, breaking down waste, and constant renewal. I believe schooling fish were just for movement, for beauty. But in nature, schooling is for survival. In Mangrove Lagoon, groups of green chromas hover above coral heads, feeding on plankton carried by the current. Their constant motion transfers energy from the open water back into the reef, like a biological pump connecting ocean and lagoon. But in my system, that small group of 3 survivors formed the seed. And after the redesign, their behavior was so natural that I was able to rebuild the school. Today, 25 green chromas perform the same function. They eat floating particles and then eat food, then release nitrates back into the cycle. Besides them, 17 pajama cardinal fish feed at night, working a night shift while the green chromas rest. Together, these 2 schools create a full 24-hour energy cycle, just like reefs in the wild, where some fish hunt by day and others by moonlight. Corals are the architect of every reef, but in my lagoon, they're also students. Each colony adapts to the conditions that define mangrove life. Lower light, gently fluctuating pH, and the gentle flow of water. My Manipora thrives under fairly low light, around 80 to 150 on the PAR scale, the same light levels you find in shaded lagoons. Its secret is with a partnership of incredibly tough microscopic algae called Durasidium, which lives inside the coral's tissue. These algae help the coral handle stress that would overwhelm more delicate SPS corals, especially when pH and temperature swings throughout the day. Meanwhile, my Blue Ridge coral, an ancient species called Heliopora, and the sole survivor of my tank crash, grows where most branching corals would struggle. It's proof that resilience isn't about fragility. It's about adaptation. In the wild, Blue Ridge coral and massive boulder corals create the backbone of shallow lagoons. In my tank, they do the same thing, binding the structure, stabilizing the sand, and creating a home for everything else. What keeps this system alive isn't what you see, it's what you don't. Every single day, billions of microscopic organisms break down waste and rebuild nutrients. Pineapple sponges, bristle worms, and tiny shrimp-like creatures called amphipods and copepods form a living conveyor belt that keeps energy flowing. Research from Mangrove Lagoon shows that more than 90% of organic material gets recycled, not wasted. And in this acrylic lagoon, that's the same cycle that's happening, quietly, invisibly, and constantly. When I stand before this system, I don't see a reef tank anymore. I see a story of recovery, of what happens when we stop fighting nature and start designing with it. Just the way the good Lord intended. Each coral that opens, each fish that finds shelter, every mangrove that grows another leaf, it tells the same story. That resilience isn't a product of perfection. It's the art of balance. My reef isn't a showcase. It's a living study. Proof that even within glass or acrylic walls, the spirit of a lagoon can endure. In the Solomon Islands, locals say the lagoon breathes, that it inhales the tide and exhales life. After years of observation and redesign, I finally understand what that means. My own lagoon breathes slowly, rhythmically, endlessly. It is alive, not because I built it, but because I listened to it. I'm John Jr., and this is the Resilient Reef Biotope. Take care of yourselves. God bless, and goodbye.